Hello and welcome to Algebra 1 Lesson 49. In this video, we're going to learn about applications of rational expressions. So in this video, basically what we're going to be doing is looking at some word problems that require equations with rational expressions. Now, the two most common problems in this arena are going to be motion word problems, which we saw back at the beginning of Algebra 1. Right? Use your distance formula there. Distance is equal to rate of speed times the amount of time traveled. And then something that's new to us is going to be these work rate problems, or some people say rate of work problems. So these are really easy to solve. We're going to get to them at the very end of the lesson. All right, so we're going to begin today with a motion word problem. So I want you to recall that we used the distance formula. Let me just highlight that real quick. The distance formula for this type of problem. So we have d is equal to r times t. Remember, this d stands for distance. The r stands for rate of speed. And t stands for time traveled. So something that's going to be new for us here is that we're going to manipulate the distance formula. And we're going to be solving it for r or t. So, for example, if I have distance is equal to rate times time, and I want to solve this for the rate. Let me highlight that. How would I go about doing that? Well, all we're going to do is realize that if t is multiplying r, to get r by itself, I just divide both sides of the equation by t. And what's going to happen is the t is going to cancel here and here. And on the right side of the equation, I'm just left with r. It's isolated. And so what I have is I have distance over time is equal to rate. Now, let's check that real quick and make sure that that makes sense. We know from the traditional distance formula that if I am going, let's say, 40 miles per hour, and I do this for 3 hours, 40 times 3 is 120. I've traveled 120 miles. Okay, so that makes sense. If I plug in the same numbers here, is that going to work? So if I plugged in 120 here, and I plugged in a 3 here, would I get 40 here? Well, yes, I would. 120 divided by 3 is, in fact, 40. Right, so we're good to go there. Now, the other thing we might have to solve for is time. So if I have distance is equal to rate times time, I'm going to use the same logic to solve for time. I want to isolate this guy, so I'm going to divide both sides of the equation by r, so I can isolate the t. So let's cancel this with this, and I'm going to be left with time is equal to distance over rate. And again, you can say, okay, using this example, if I plugged in 120 here, and I plugged in a 40 there, 120 divided by 40 is in fact 3, so we're good to go. All right, so let's go ahead and take a look at the first problem. So the local river has a current of 3 miles per hour. A boat takes the same amount of time to go 24 miles downstream, okay, that's going with the current, in case you don't know that, as it does to go 12 miles upstream. Upstream is against the current. What is the speed of the boat in still water? So it might seem like this is a difficult problem, but it's really not. Let's go ahead and make a little table to kind of organize our information. The two things we're going to think about is the scenario where we're going downstream, again, that's with the current, and the scenario where we're going to go upstream, and that's against the current. So let's scroll down here real quick. So we'll kind of think about, okay, we have upstream, and we have downstream. Okay, so let me just draw a little line here. Now, the components of the distance formula, let's think about those. So we have distance, which I'm just going to abbreviate with a d. We have the rate of speed, which I'm going to use an r for. And then we have the time. So what I want to do here is just fill in this table and get the information that I'm going to need to create an equation that's going to allow me to solve and figure out an answer for this problem. So let's scroll back up to the top real quick. All right, so it tells us in the problem that the boat is going 24 miles downstream in the same amount of time as it does to go 12 miles upstream. So for the distance, I'm going to put 24 miles under downstream and 12 miles under upstream. Okay, so I'm going to write 12 here and 24 here. Again, the distance when I'm going upstream is 12 miles. The distance when I'm going downstream is 24 miles. Now let's think about the rate. So when we think about the rate of speed, again, this is how fast we're traveling. The only information we're really given is that the local river has a current of 3 miles per hour. It doesn't give us any other information. Now, what you're supposed to know here is that if you're going upstream, you are fighting the current, right? So whatever the amount of speed you're going in miles per hour, like if you're going in still water, you've got to subtract 3 away from that because you're fighting the current. So if I let a variable like x, let's say let x equal the speed of the boat in still water. What would happen is the speed when I am going upstream would be x, the speed of the boat in still water, minus 3, because that's the speed of the current, and that's what I'm fighting. So let's scroll down and put that. So again, for the upstream speed, it's going to be x, the speed of the boat in still water, minus 3, the speed of the current. And then for the downstream speed, it's just as easy, right? We think about the speed of the boat in still water is x. And then now if I'm going downstream, that means I'm going with the current. So the current is pushing on my boat. It's making me go faster by 3 miles an hour. So I would add 3 to that x. So x plus 3 is the speed of the boat going downstream. X minus 3 is the speed of the boat going upstream. Now, how do I go about getting a time? Well, reading back through the problem, the only thing it really says about the time is that it takes the same amount of time to go 24 miles downstream as it does to go 12 miles upstream. So what I can do here, as we talked about a little while ago, is I can get a time for each one, and then I can set those times equal to each other. So let's take that one step at a time. To get a time, remember, the d equals r times t can be solved for t. So if I divide both sides of the equation by r to isolate t, as we did earlier, this cancels with this, and I've got t by itself. So time is equal to distance over rate. I have a distance here, I have a rate here, so I'm going to have a time. The distance in this case is 12. The rate in this case is x minus 3. So my time for going upstream is 12 over x minus 3. Now for downstream, I can do the same exact thing. My time is going to be 24, which is my distance, over x plus 3, which is my rate. Now that we have all this information figured out, we want to go ahead and set up an equation. And as I told you, when we look at this problem, it tells us that a boat takes the same amount of time to go 24 miles downstream as it does to go 12 miles upstream. So that means I could set the two times equal to each other, and I could solve for x, and I'd figure out what the speed of the boat is in still water. Let me erase this real quick. So I have the time for upstream, which is 12 over x minus 3. And I'm going to set this equal to the time for downstream, which is 24 over x plus 3. So in the last section, we learned how to solve equations of this form. We learned that, and let me kind of scroll this part down. So one way we can do this is we can find the LCD and multiply both sides of the equation by the LCD, clear the equation of any denominators, and kind of go from there. But in this particular scenario, the easiest thing to do would be to cross multiply. Remember that from proportions, right? I can multiply x minus 3, that quantity, times 24. And I can multiply x plus 3, that quantity, times 12. And why is that a shortcut? Well, the LCD here is going to be what? It's x minus 3 times x plus 3. So if I multiply both sides of the equation by this LCD, well, what's going to happen is this denominator here is going to cancel, and I'm going to multiply 24 by x minus 3, which is exactly what I'm doing when I'm cross multiplying, right? This would be 24 times the quantity x minus 3 is equal to, same thing over here, the x minus 3 would cancel, and I'd be multiplying 12 by x plus 3. That's what I'm doing when I'm cross multiplying. So So 12 times the quantity x plus 3. So that's a little shortcut for you to kind of speed up the process if you get this scenario. So let's erase this real quick. And so 24 times x is 24x. And then 24 times negative 3 is going to give me negative 72. And this is equal to, over here we have 12 times x, that's 12x. And then we have 12 times 3, that's 36. Okay, so let's solve this equation. Very, very easy to do. I'm just going to add 72 to both sides of the equation. And I'm going to subtract 12x from both sides of the equation. So this is going to cancel, and this is going to cancel. 24x minus 12x is 12x. So this is 12x. And this is equal to 36 plus 72, which is 108. Okay, as my last step here, I'm going to divide both sides of the equation by 12. And this is going to cancel with this. And I'm going to have that x is equal to 9. So I've found the answer to the problem. X, again, was the speed of the boat in still water. And that's what I was trying to figure out. So x is equal to 9. So the speed of the boat in still water is 9 miles per hour. So let's go back up to the top and write that. So I'm just going to write that the boat travels 9 miles per hour in still water. And that answers our question there. What is the speed of the boat in still water? So how would we check something like this? Well, let's read back through the problem real quick. So the local river has a current of 3 miles per hour. A boat takes the same amount of time to go 24 miles downstream, again with the current, as it does to go 12 miles upstream, again against the current. So what is the speed of the boat in still water? So I know at this point that upstream, my rate of speed is going to be what? Well, x is 9. So I plug in a 9 there. 9 minus 3 is 6. So in other words, I know that the time that it takes to go 12 miles upstream should be 12 over 9 minus 3, or 12 over 6, which is 2. And is that equal to the amount of time that it takes to go downstream? Well, my speed downstream, if I replace this x with a 9 plus 3 is 12 miles an hour. You'd basically have 24 over, again, 9 plus 3 is 12, so 24 over 12 would be 2. So it takes the same amount of time, which is 2 hours, to go upstream 12 miles as it does to go downstream 24 miles. So we have the correct answer here, right? The speed of the boat in still water is 9 miles per hour. So the next type of problem we're going to deal with is known as a work rate problem, or some of you will hear it called a rate of work problem. Either way, these type of problems involve how much time it takes to complete a job. So in this scenario, working alone, Paul can pour a large concrete driveway in 5 hours. Natalie can pour the same driveway in 7 hours. How long would it take to complete this job if they worked together? So when you first start thinking about it, if you don't get any direction on it, it's kind of hard to figure out how to solve this. I know how long it would take for Paul to pour a driveway. It's 5 hours. It says it right there. I know how long it would take for Natalie to pour the same driveway. It's 7 hours. But if I combine their work rates and they work together, how long is it going to take? Well, the first thing I have to do is break this down into 1 unit of time. In this particular case, we're talking about hours. Now, for these problems, you might talk about days or weeks or minutes. Whatever it is, you're going to break it down into one of those units of time. So let me kind of scroll down a little bit, get some room going. And I'm going to just think about, okay, in 1 hour, because I want 1 unit of whatever time I'm dealing with. I'm dealing with hours, so I want one of those. What can Paul do in 1 hour? Well, Paul completes the job in 5 hours, so in 1 hour, he's done 1/5 of the job. 1/5 of, you could say, the driveway or of just the job, just to be generic. Then Natalie she's a little bit slower. It takes her 7 hours to complete the job. So in 1 hour, she's 1/7 complete. So 1/7 of the job, or again, you could say of the driveway. Okay, so what I want to do next is sum the individual contributions from these two people. If I do that, I'm going to get the amount of the job that is completed by both of them in a 1 hour period, again, working together. So what I want to do here is do 1/5, that's the contribution from Paul, plus 1/7, that's the contribution from Natalie. So I would get a common denominator here. This would be times 5/5. This would be times 7/7. And this would be what? 7 plus 5 over, 7 times 5 is 35. So 7 plus 5 is 12. So this would be 12/35 here. And what 12/35 is, that's the contribution, again, by both of them in a 1 hour period. So let me just kind of scroll this down here and just say 12/35 is the amount of the job completed in 1 hour. Now the next thing I want to do, let me kind of go back up to the problem. I'm going to let x here be equal to the number of hours to complete the job if they work together. So going back down now, we have 12/35, or 12/35 is the amount of the job completed in 1 hour. If I multiply this by x, which is the number of hours, number of hours to complete the job, I'm going to get 1. Okay, and the reason we use 1 is it's one completed job. Now, to make this make sense for you, because I know when you start dealing with this, it's like, why would you set it equal to 1, so on and so forth. Let me just scroll down real quick and give you a very easy scenario. Let's say me and you paint a room in 4 hours, working together. So that's very, very simple. So in 1 hour, we would paint 1/4 of the room. If I didn't know how many hours it would take, let's say I multiplied that by x, and then I filled in that with a 4, well, I know that 4 times 1/4 is equal to 1. It's because we're completing one room, or one job, however you want to think about that. So that's our goal, is to set this equal to 1, because we are trying to see how long it's going to take to complete one job. Okay, so let's go back up. And now all we need to do is solve this very simple equation. If I have 12/35 x is equal to 1, all I need to do is multiply both sides by the reciprocal. Multiply this by 35/12 and this by 35/12. And I'm going to get what? This is going to cancel. I'll have x is equal to 35/12. Now, let's go back up to the top and make sense of this. So I'm just going to answer it first. So how long would it take for them to complete this job if they work together? It would take 35/12 hours to complete the job. And you can do the division on that. It's not going to give you an exact value, but it would be 2.91 with a 6 that repeats forever. So you could say about, approximately 2.92 hours if you wanted to just give an estimate. But if you wanted to be precise, which it's good to do on a test, I would just write that fraction that you got, which is 35/12 hours. Now, let's make sure that this makes sense. So again, working alone, Paul can pour a large concrete driveway in 5 hours. Natalie can pour the same driveway in 7 hours. How long would it take for them to complete this job if they work together? So what I'm going to do here is I'm going to take 35/12, which is the number of hours they work for. I'm going to multiply this by the rate of speed that Paul works at, which is 1/5. And then plus, I'm going to do 35/12 times the rate of speed that Natalie works at, which is 1/7. And let's see if this equals 1, right? One completed job. So this divided by this would give me 7. So I'd have 7/12. So that means that in this amount of time, 35/12 hours, Paul completes 7/12 of that driveway. He completes 7/12 of that job, you might want to say. And then Natalie's contribution is less because she works at a slower rate. This divided by this would give me 5. She does 5/12 of the job. So in this amount of time, Paul contributes 7/12. Natalie contributes 5/12, which equals what? 7 plus 5 is 12. 12 over 12 is 1. So they do complete one job.